Hello and welcome to Call of Chemistry. In this video, we will discuss about ionic product and solubility product, and also we will solve some problem regarding this topic. So let's start. Firstly, we will understand when a solute gets soluble in solvent. The answer is when solubility product greater than ionic product, then the solute gets soluble. But if ionic product greater than solubility product, then precipitation takes place. Now, what is ionic product? We will understand ionic product by an example. Suppose a 0.1 molar aqueous BaCl2 solution is taken. And we know that BaCl2 dissociates as follows: Ba2 plus 2Cl minus, and the concentration of BaCl2 solution is 0.1 molar. And as after dissociation, one equivalent of Ba2 plus ion is there, so the concentration of Ba2 plus ion will be 0.1 molar. And as two equivalent of chloride ion is there, so concentration of chloride ion in BaCl2 will be 2 into 0.1 molar. So the ionic product will be simply concentration of Ba2 plus into concentration of Cl minus. So it is 0.1 into 2 into 0.1. So it will be 0.02. This is how we calculate the ionic product. Simply multiply the concentration of cation and the concentration of anion. Now how we calculate solubility product? Solubility product is concentration of Ba2 plus into concentration of Cl minus square. When we calculate the solubility product, we have to take the coefficient into the power of the ion. So here the coefficient of Ba2 plus is 1, so here is the power is 1, and coefficient of chloride is 2, so there is power is 2. So solubility product will be 0.1 into 2 into 0.1 square, so it will be 0.004. So here you see that ionic product is greater than the solubility product. Here ionic product is greater than the solubility product. Hence BaCl2 gets precipitated. And we get a white precipitate. Now how can we find the solubility product? Well, here I am not going to tell you any formula because it is easier to understand the method than remembering a formula. We will understand the method of finding solubility product by an example. Suppose an aqueous solution of 0.5 molar aluminum sulfate is taken. So 0.5 molar aluminum sulfate is taken. So we know that aluminum sulfate dissociates as follows: 2Al3 plus 3SO4 2 minus, and concentration of aluminum sulfate is 0.5 molar. This is also called the solubility of aluminum sulfate. Now, as 2 equivalent of Al3 plus is there, so concentration of aluminum 3 plus in aluminum sulfate is 2 into 0.5 molar, and as 3 equivalent of sulfate ion is there, so concentration of sulfate ion in aqueous solution of aluminum sulfate will be 3 into 0.5. Now, the solubility product or it is termed as KSP is concentration of Al3 plus square into concentration of sulfate ion cube. So previously we have told that while finding the solubility product we have to take this coefficient into the power. So here 2 equivalent of aluminum is there, so we take this 2 into the power of concentration of aluminum 3 plus, and 3 equivalent of sulfate ion is there, so we have take this 3 into the power of sulfate ion. So simply put the values: 2 into 0.5 square into 3 into 0.5 cube. So you get that 3.375. Now we calculate the ionic product. Ionic product is Al3 plus into concentration of sulfate 2 minus. So it is 2 into 0.5 into 3 into 0.5. So it is 1.5. So here you can see that solubility product is greater than the ionic product. That's how we calculate the ionic product and solubility product. Now we move on to a problem. So here we have to calculate the PCl. PCl means minus log concentration of Cl minus. We have to calculate this. So in the problem, AgNO3 is added in solution of NaCl. So the reaction will be AgNO3 plus NaCl, and we get NaNO3 and AgCl. Now the solubility product of AgCl is given. From that we have to calculate the concentration of Cl minus, then we have to reach this PCl. So Ag plus Cl minus, and we get AgCl. So if we write millimoles here, that is initial millimole and final millimole, and 60 ml of 0.1 molar AgNO3 is added, so the millimole will be 60 into 0.1, that is 6, and the millimoles of chloride is, we have provided 50 ml of 0.1 molar NaCl solution, so millimoles of chloride ion will be 50 into 0.1, that is 5, and after the reaction 5 millimole of chloride reacts with 5 millimole of Ag plus to give 5 millimole of AgCl, so 6 minus 5, that is 1 millimole of Ag plus remains unreacted, and here 5 millimoles of chloride reacts, so it will be 0. 5 minus 5, that is 0, and we get 5 millimoles of AgCl. So concentration of Ag plus will be millimole of Ag plus remains unreacted upon total volume. So 1 millimole of Ag plus remains unreacted. So here 1 millimole we have written, and the total volume is 60 ml of AgNH is added to 50 ml of NaCl solution. So total volume is 60 plus 50 ml. So you can get that 1 upon 110 molar, that is 9.1 into 10 to the power minus 3 molar. Now we know that Ag plus into concentration of Ag plus into concentration of Cl minus is nothing but Asp of AgCl. So we taking the negative logarithm in both sides. So we get minus log concentration of Ag plus minus log concentration of Cl minus and minus log Ksp. And we have to put the values. Minus log concentration of Ag plus we have calculated earlier, that is 9.1 into 10 to the power minus 3 is 9.1 into 10 to the power minus 3, that is, and it is nothing but PCl minus log concentration of Cl minus, so it is PCl and minus log, and we have the Ksp value that is given, that is 10 to the power minus 10. So this is 2.04 plus PCl and this is 10. So PCl will be 10 minus 2.04, that is 7.96. This is how we calculate the PCl value. Now we move on to the next problem. So in the problem, the solubility product of lead sulfate is given that it is concentration of Pb2 plus into concentration of sulfate, and we know that PbSO4 is Pb2 dissociates as Pb2 plus plus sulfate. So here the coefficients of 1, so the power will be 1, and it is given that now in 10 to the power minus 3 molar sodium sulfate solution, let solubility of lead sulfate is S, because both in sodium sulfate and lead sulfate, sulfate ion is the common ion, so concentration of Pb2 plus will be S and concentration of sulfate ion will be S plus 10 to the power minus 3, as sulfate ion is the common ion in both sodium sulfate and lead sulfate. So concentration of sulfate in 10 to the power minus 3 molar N2SO4 solution will be S plus 10 to the power minus 3. Therefore S into S plus 10 to the power minus 3 is equal to 1.3 into 10 to the power minus 8, that is given the solubility product of lead sulfate. So here S into S plus 10 to the power minus 3 is 1.3 into 10 to the power minus 8. So S square plus 10 to the power minus 3 into S minus 1.3 into 10 to the power minus 8 is equal to 0. From that quadratic equation, we can calculate the value of S is 1.28 into 10 to the power minus 5 molar. So it is 1.28 into 10 to the power minus 5 mole per liter. So 1 liter of solution contains 1.28 into 10 to the power minus 5 moles of lead sulfate. So 5 liter of sodium sulfate solution contains 5 into 1.28 into 10 to the power minus 5 moles of PbSO4, that is 6.40 into 10 to the power minus 5 moles. And we have to mix 20 ml of 2 into 10 to the power minus 4 molar of lead nitrate with 80 ml of 10 to the power minus 4 molar sodium sulfate. So 20 ml of 2 into 10 to the power minus 4 molar lead nitrate plus 80 ml of 10 to the power minus 4 molar sodium sulfate. So the final volume becomes 20 plus 80 ml, that is 100 ml. So here the concentration of lead nitrate will be 20 into 2 into 10 to the power minus 4 upon 100, that is 20 into 2 into 10 to the power minus 4, that is millimole, and it is the volume ml, so we can get the molarity. So it is 4 into 10 to the power minus 5 molar, that is the concentration of Pb2 plus, and similarly concentration of Na2SO4 is 80 into 10 to the power minus 4 upon 100, that is millimole, and it is ml, and that is 8 into 10 to the power minus 5 molar, that is the concentration of sulfate ion. So the ionic product of lead sulfate will be concentration of Pb2 plus into concentration of sulfate, that is 4 into 10 to the power minus 5 into 8 into 10 to the power minus 5, that is 32 into 10 to the power minus 10. Or we can say that it is 0.32 into 10 to the power minus 8. But the solubility product of lead sulfate is given that 1.3 into 10 to the power minus 8. So we can say that solubility product is greater than ionic product, that is this value is the ionic product value and this value is the solubility product. So solubility product is greater than ionic product. So we can say that there will be no precipitation, as the value of solubility product is greater than ionic product, so it is soluble, so there will be no precipitation. This is how we solve this problem. So by this I am stopping here. If you have any doubt, please let me know in the comment section. Please like, share and subscribe my channel. Thank you.